Good day, my amiable viewers. You're welcome back to channel. Welcome back to class 2. Please, if you are not be sharing this video, kindly do me a way to share it. Thank you very much. Today, we are going to have a look at some areas in acid base and salt. First of all, we are going to start with water crystallization. Water crystallization are definite amount of water some compounds chemically combine with when they are produced from aqueous solution of their salt. Example of such compounds, you have CuSO4 10H2O. This means water of this decahydrate, water of crystallization. The name of this compound is copper 2 tetraoxo sulfate 6 decahydrate. We also have some other ones. You have Na2CO3.5H2O. This sodium triisocarbonate 4 pentahydrate. Sodium triisocarbonate 4 pentahydrate. You can also have decahydrate. Remember, the water of crystallization, they are loose, so they can easily decompose up when heated. When it's 1, mono. When it's 2, di. When it's 3, tri, and so on and so forth. Remember the one we said in our previous video, we said do decahydrate 12. So that is that on water of crystallization. Then you also have another term we come across, hydrated salt. These are salts that contains water crystallization. So when you have any salt like the one we mentioned previously, CuSO4.10H2O, normally they give you SH2O, like in most of the examination bodies. All these ones means water crystallization. Because they contain water crystallization, we call them hydrated salts. So hydrated salts are salts that contain water crystallization. Then again, you have another one we call anhydrous salt. So these are residue left behind when you heat hydrated salts. The salt that contain water crystallization, when you heat them, the residue left behind is called anhydrous salt. You can have Na2CO3. This from 10H2O. If this one heated and goes off, this one is now called anhydrous salt. When the water crystallization has been removed, what you have left is anhydrous salt. Now, let us have a look at another important area, which may be the last part of today's discussion. You have characteristics of salt. Like I just said, there are 3 major characteristics of salts. You have the deliquescent, substances. You have the efflorescent. Okay, let's use the other one first. Hygroscopic substances. Then you have the efflorescent. Efflorescent substances. Deliquescent substances are those substances which absorb water from the atmosphere or from the environment and dissolve in it to form solutions. Example of such salts are, or such substances, because some of them are not actually salts, are KOH, which is a base, NaOH, we have FeCl3, then CaCl2, etc. All these substances, when they absorb water, they dissolve in it and form solution. For example, if you are using them to prepare solution in the laboratory, maybe for titration, sodium hydroxide or potassium hydroxide, or for even salt analysis, they are not usually overexposed. When you expose them to the environment before you come back to use it, they will turn to aqueous solution because they absorb water from the atmosphere or from the environment, dissolve in them to form solutions. The first one is potassium hydroxide, which are already conversant with. The other one is sodium hydroxide. We have already mentioned this when we were discussing bases. Iron 3 chloride, calcium chloride. All these substances are known as deliquescent substances. The second on the line is hygroscopic. Just like deliquescent substances, hygroscopic substances also absorb water from the atmosphere or from the environment, but do not dissolve in it to form solution. Instead, they become wet. Example is concentrated tetrahydrosulfuric acid, calcium oxide, copper 2 oxide, etc. Because they do not dissolve in it to form solution, rather they become wet, they are normally very good or useful as dry agent. Then you have the last one, which is the efflorescence. Efflorescent substances are those substances which loses part or all of their water of crystallization when they are exposed to the atmosphere. When you leave them to the atmosphere, they lose some of their water of crystallization, which we said before is the fixed amount certain compounds have when they are produced from their aqueous solution. For example, you have Na2CO3 or 10H2O. And I believe by now you know that when you have dot water, it means it's the water of crystallization.